This is the second part of a Level 1 Functional Skills Maths paper from NCFE. In this part you can use a calculator. Activity 2. Healthy Eating Cafe. John is opening a healthy eating cafe. He looks for a property with a sitting area for 20 customers. This is a scale plan of the sitting area in one property he finds. The drawing has a scale of 1 cm to 150 cm. The recommended maximum number of customers in a cafe is the sitting area in square meters divided by 1.5. Is this property suitable for 20 customers? Show how you decide. So we're going to first work out the area in square meters and then divide that by 1.5. So we've got the plan and the scale is 1 cm to 150. So what about 4 centimeters? So to get from 1 to 4 we multiplied by 4. So we'll do the same on the other side. And that gives us 600. That is centimeters because we input centimeters. So we've got the length. What about the width? So again, that is 3 centimeters. So we'll multiply 150 by 3, which gives us 450 centimeters. Now let's convert these into meters. In 1 meter, there are 100 centimeters. Centi can help us remember, just like century or the number of cents in a euro. So 600 centimeters, that will be 6 meters. So divided by 100. 450 centimeters, that will be 4.5 meters. So again, you can divide 450 by 100 to get 4.5. So we've got the dimensions now in reality for this. That is 6 meters by 4.5 meters. To get the area, we'll multiply these together, and that gives us 27 square meters. So 27, divide that by 1.5, because that's what we're told there, gives us 18. So that's the recommended maximum number of customers. Is this property suitable for 20 customers? We're going to say no. Only 18. Another property has a kitchen that has an area of 7 meters squared. What is 7 squared? So 7 squared, that is 7 times 7. So 7 multiplied by itself, and that is 49. John wants his menu to offer healthy food. He reads that 617,000 people went to hospital last year with illness caused by poor diet. What is 617,000 in numbers? So 617,000. You could even add a comma if that helps you. John buys food in preparation for his opening day. So we've got ingredients, price per item, number of items, total price per ingredient. Complete the table to show how much has John spent. So we've got cabbage, 64 pence, number of items, that is 5. So we're going to multiply them together. We need to give the final answer in pounds, so we're going to try and give this in pounds as well. So by multiplying 64 by 5, we get 320. Now, in pounds, that is £3.20, because 320 was pence, because we input pence. Now, 30 times 20 for the pack of carrots gives us 600, and that's pence, so £6. Pack of tomatoes, £1.25 times 11 gives us £13.75. We don't need to convert this because it's already in pounds. And we've got 50p times 9, which gives us 450, so that is £4.50. Now £1 times 15, so that gives us £15. And adding all of these together using a calculator, we get £42.45. John fills a fruit bowl with 6 apples, 4 plums, 5 oranges and 3 pears. The first customer chooses a piece of fruit at random. What is the probability that they choose a pear? So we've got 3 pears out of the number of fruits in total, so that is 3 plus 5 plus 4 plus 6. Now you could use a calculator here, but 4 and 6 is 10. Add 5, that's 15, and a 3, that is 18. So 3 18s. Can we simplify this further? We can divide this by 3 and this by 3. So that would be 1/6. John looks at the bills from all the customers. The range of amounts spent is £22.46. The largest bill is £24.56. What was the smallest bill? So we know that the range is the difference between the highest amount and the lowest amount. So we've got the range being £22.46. So if I take away £22.46 from £24.56, because that's the largest or the highest amount, then it should give us the smallest bill. So 6 take away 6 is 0, 5 take away 4 is 1, 4 take away 2 is 2, 2 take away 2 is 0. So £2.10 is the difference. So that is the smallest bill. John asks his customers to rate the cafe. The customers give 4 times as many good ratings as excellent ratings. The customers also give 3 times as many excellent ratings as satisfactory ratings. 60 customers rated the cafe as good. How many customers rated the cafe as satisfactory? So they gave 4 times as many good ratings as excellent ratings. So if that is 60, and that is 4 times the excellent ratings, we can do 60 divided by 4, which gives us 15. So that's how many excellent ratings. So let's just double check. 4 times as many good ratings as excellent ratings. So 15 excellent, 4 times that is 60. The customers also give 3 times as many excellent ratings as satisfactory ratings. So excellent, we've got 15. So that is 3 times as many as satisfactory ratings. So 15 divided by 3 gives us 5. So 5 times 3 gives us 15. Question is, how many customers rated the cafe as satisfactory? And that is 5. Activity 3, Go-karting. Hamid organises a go-karting party for himself and 5 friends. The cost is £29.95 per person. He uses rounding to estimate the cost for the whole group. How much is the estimated cost? So £29.95, that is very close to £30. And we'll multiply that by 5 friends and Hamid, that is 6. So times 6 gives us 180. Hamid needs to book transport. A small minibus will cost £45. He has a voucher for 5% off. How much will the minibus cost Hamid? So 5% of 45, that is 5 out of 100 of the amount, which is £45. So in the calculator we'll do 5 divided by 100 times 45, which gives us 2.25. So 45, take away the 2.25, gives us 42.75. So £42.75. The safety instructions show a plan view of the go-kart. Hamid says the go-kart is 1.5 meters high, 2 meters long and 0.6 meters wide. Is Hamid correct? Explain your answer. Having a look, 1.5 meters, that is the width of the go-kart, not the height. And we've got the length and 0.6 meters wide. That's definitely not the case because it's 1.5. So we can say no, and the width is 1.5 meters. This table shows the times Hamid and 2 of his friends take to complete their first lap. Write these times in order of fastest to slowest. So fastest, we're looking for the smallest number here. So they both begin with 39. So we're going to need to look at the next digit. That's a 0, that's a 3, and that's a 1. So 0, that is the lowest. So we're going to have to put that first. So 39.041. And then between 3 and 1, this is the lowest. So that would be the next one, 39.12. And then 39.3. Which person had the fastest lap? Well, the fastest was this one, and that's Hamid. Hamid looks at the times on the leaderboard for that day. The times are in seconds. Calculate the mean time. So we'll have to add and then divide that total by 7 because we've got 7 numbers. So 26.52 plus 27.5 plus 28.9 plus 29.82 plus 30.18 plus 31.2 plus 31.4, and that gives us 205.52. So we'll now divide that by 7. which is 29.36. Here are people's lap times in seconds over the last week. Using the lap times, complete this frequency table. So we've got lap time in seconds, 20 to 25, 26 to 30, 31 to 35, 36 to 40. So we're going to add the frequency in the other column. So let's start with 20 to 25. So here is 1, 2, 3, 4, 5. 26 to 30, 1, 2, 3, 4, 5, 6. 31 to 35, 1, 2, 3, 4, so that's 4 of them. 36 to 40, 1, 2, 3, 4. Let's just double check. So we've got 10, 15, 19 in total. Let's see, is that 19 here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we must have filled this in correctly. Put your results on this bar chart. So lap time in seconds, we're going to show that horizontally. And we've got, as we said, 20 to 25. Let's just double check. That looks okay. And then we have frequency of people. The highest is 6. So we can start with 0, 1, 2, 3, 4, 5, 6, and 7. So let's put frequency of people here. And so from 20 to 25 there were 5 people, so that's going to go up to 5. (26 to 30) that goes up to 6. (31 to 35) that goes up to 4. And also 36 to 40 that goes up to 4. Now when you do this on paper using a pencil and a ruler, it's going to look much neater, but at least it gives you the idea. And you could colour the bars in or leave them as they are, because that's absolutely fine too. The friends go to lunch after they have raced. Bethany has a voucher giving her 35% off. Ikra has a voucher for 2/5 off. Who has the better discount? Show how you decide. So you could convert them both into fractions or both into percentages. I'll go with percentages given that we can use a calculator here. So we've got 35% already. For the 2/5, that is 2 divided by 5. So in the calculator, if you do 2 divided by 5, you get 0.4. 0.4 is the same as 0.40. And if I link this to money, it's probably going to help you. So you'd know, in this case, that would be 40 pence. And that's 40% as well. Pence, percent. They both work out of 100. So that's 40%. So which one is the better value one? This is the better discount. So Ikra has a better discount. Activity 4, childcare course. Natalie teaches a childcare course. She is planning a trip with 16 students. They have volunteered to work for 2 weeks abroad. They need to raise £2,000 per student to pay for the trip. They have already raised 7/8 of the money needed. How much money have they raised so far? So they need to raise £2,000 per student, and it's 16 of them. So 16 times 2,000 gives us 32,000. They've already raised 7/8 of that. So 7/8 so that's 7 out of the 8. So total is 32,000. So 32,000, if I divide that by 8, gives me what one of these slices is worth, which is 4,000. Now we've got 7 of these slices that have been raised already. So 7 times 4,000, that gives us 28,000. So £28,000 has been raised already. They have 1/8 left to raise. Write 1/8 in figures. So 1/8, that is this. Natalie packs children's clothes into boxes. Each box is a cube with a side length of 50 centimeters. The clothes weigh 350 grams per 500 cubic centimeters. Calculate the weight of the clothes in each box when the box is full. Give your answer in kilograms. So that would be 50 centimeters, 50 and 50. So to work out the volume of the cube, we're going to do 50 times 50 times 50, which is 125,000 centimeters cubed. Now, the clothes weigh 350 grams per 500 centimeters cubed. So we're going to divide 125,000 by 500 to see how many of those we have, which gives us 250. So 250 lots of 500 cubic centimeters. So now 250 times 350 grams gives us 87,500 grams. We've got to give our answer in kilograms. So in 1 kilogram, there are 1,000 grams. So kg, K means 1,000, just like we use it in everyday life. So if we divide 87,500 by 1,000, that gives us 87.5 kilograms. So 87.5 is the final answer. When the group get on the plane, the pilot announces that the temperature is 10 degrees Celsius at their destination. It is -2 degrees Celsius in the UK. What is the difference in temperature from the UK to their destination? So if you think of a thermometer, to have 0 degrees there, -1 or -1, -2, and then it goes up to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So from the 10 to the 0, that is 10 degrees. From the 0 to the -2, that is 2 degrees. So all together, that is 12 degrees. That's the difference in temperature. 12 degrees Celsius. The volunteers are going to help children in a home. The ratio of boys to girls in the home is 1 to 3. There are 80 children in total. 75% of the boys and 40% of the girls are under 10. How many boys and how many girls are under 10? So first of all, we've got 1 to 3, the ratio of boys to girls, and we've got 80 children in total. So 3 and the 1, that is 4 units, and we've got 80 children. To get from 4 to 80, we've multiplied by 20. So each of these will be multiplied by 20. So 1 times 20 gives us 20, so that's how many boys. And 3 times 20 gives us 60, so that's how many girls. So 75% of the boys are under 10. So 75%, that is 3/4. 3/4 of 20, that's boys. So 20 divided by 4 times 3, 20 divided by 4, that is 5 times 3, that is 15. So 15 boys are under 10. Now looking at the girls, we've got 60 girls, so 40% of the girls are under 10. 40%, that is 40 out of 100, because that's what percent means, of the number, that is 60. So we can do this using a calculator, and that is 24 girls under 10. The question is, how many boys and how many girls are under 10? So we can say boys 15, girls 24. Natalie knows that only 60% of the children can write their name. She chooses one of the children at random to work with. On the scale, mark the probability that this child can write their name. So that is 60%. So on a scale from 0 to 1, that's going to be 0.6 or 6 out of 10. So how many divisions do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is 6 out of 10. So 1, 2, 3, 4, 5, 6. So this is where we're gonna stop. write 60% as a decimal. So again, we've just said that. That was 0.6. Which was this point here, because it's between 0 and 1. And that is 0.6. You could also do 60 divided by 100. And this is the end of the paper.